physicists have reached beyond Albert Einstein to develop new equations hypothesizing that singularities don't exist inside black holes. When stars collapse, they create black holes, which are everywhere throughout the universe and therefore important to be studied. Black holes are mysterious objects with an outer edge called an event horizon, which traps everything, including light. Einstein's theory of general relativity predicted that once an object falls inside an event horizon, it ends up at the center of the black hole, a region called the Singularity, where it's completely crushed and destroyed, never again to enter our universe. At this point of singularity, gravitational attraction becomes infinite, and all the known laws of physics break down, including Albert Einstein's. Although they've had little success until now, there's a cohort of theoretical physicists who have been questioning if singularities really exist. They've developed complex mathematical equations over the past few decades, but they've really not amounted to anything serious. Now, Associate Professor Parampret Singh and colleagues from Louisiana State University have developed new mathematical equations which they claim go beyond Albert Einstein's theory of general relativity, overcoming its key limitation, the central singularity of a black hole. Their work's been reported in the journals Physical Review Letters and Physical Review D. Now, if you were a fan of SpaceTime's predecessor Star Stuff back in the 1990s, you'll remember our tutorial on loop quantum gravity. Theoretical physicists developed loop quantum gravity as a means of trying to marry the laws of quantum mechanics, which explains the physics of the very small, with relativity theory, which explains gravity and the dynamics of space and time on the cosmological scale. The new equations attempt to describe black holes in loop quantum gravity, in the process showing that black hole singularities need not exist. Singh says that in Einstein's theory, space-time is a sort of fabric of the universe, which can be divided up as small as one wants. He says this is essentially the cause of the singularity where the gravitational field becomes infinite. However, in loop quantum gravity, the fabric of space-time has a more tile-like structure, which cannot be divided beyond the smallest tile. Singh and colleagues believe they've now shown this is the case inside a black hole, and therefore there can be no singularity. However, in loop quantum gravity, the fabric of space-time has a tile-like structure, which cannot be divided beyond the smallest tile. In other words, there's a set minimum scale. Singh and colleagues claim they've now shown this is the case inside black holes, and therefore there can be no singularities. According to their interpretation of loop quantum gravity, instead of a singularity, there's a funnel to another branch of space-time. These tile-like units of geometry, called quantum excitations, and which Singh and colleagues believe resolves the singularity problem, are orders of magnitude smaller than can be detected with today's best technology. But the authors insist their mathematical equations can still predict their behavior. Singh says Louisiana State University has been developing state-of-the-art computational techniques in order to extract physical consequences from these physical equations using supercomputers, in the process bringing science closer to reliably testing loop quantum gravity. He believes Einstein's theories fail not only at the center of black holes, but also to explain how the universe was created from the Big Bang singularity. In fact, a decade ago, he and some colleagues began extending physics beyond the Big Bang in order to make new predictions using loop quantum gravity. Using the mathematical equations and computational techniques of loop quantum gravity as they've developed it, they've predicted that the Big Bang is in fact replaced by a Big Bounce. All they need to do now is prove it. So, what exactly is loop quantum gravity? Since the 1980s, M-theory, better known as string theory, has been, as we've already pointed out, the favoured model for unifying Albert Einstein's general theory of relativity, which explains the physics of gravity on the cosmic scale, with quantum mechanics and later quantum field theory, which explains physics at the subatomic level. The problem is, these two theories are incompatible. In other words, one theory loses its predictive power whenever the other theory comes into play. And that's where string theory comes into play. Its basic premise is that the most fundamental particles in nature aren't point-like, but rather more like vibrating strings. So, when you look inside an atom, for example, you'll find it's made up of protons, neutrons, and electrons. And when you look inside, well, say a proton or a neutron, you'll find these elemental particles called quarks. And then when you look inside one of these elemental particles, be they a quark or a neutrino or a photon or an electron, you'll find these vibrating strings of energy. Strings vibrating at one frequency might form an electron, Vibrating at a slightly different frequency will see them form a photon, and at yet another frequency they could form a type of quark or neutrino. However, for string theory to work, the four-dimensional space-time universe we understand around us actually needs at least 6 extra dimensions. Now, we don't see these extra dimensions because, according to theorists, they're extremely compact and tightly curled up. Physicists working on different versions of string theory have come up with different additional dimensions. Some have 6, others 10, some have 11, others 13. There are even 21 and 23 dimensional universes, according to which version of superstring theory you believe is valid. Now, all of these are different manifestations of an underlying theory called M-theory. M-theory suggests that the 3 space dimensions of our universe are actually simply on the surface of a membrane, that's the M, which exists in another dimension, and there are other membranes floating around nearby in the multiverse. Now, when 2 of these membranes come into contact with each other, that causes a singularity, such as that at the center of a black hole or at the start of the Big Bang 13.8 billion years ago. Now, if all this is getting a bit too much for you, well, there's a helping hand in the form of an alternative theory called loop quantum gravity. Loop quantum gravity is elegantly simple. It works on the existing 4 dimensions of space-time, which we already know, so there's no need for any messy additional unseen dimensions. Instead of the basic principles of our universe being vibrating strings, as string theory predicts, loop quantum gravity says the basic structure of space-time is made up of tiny loops, just 10 to the minus 33 of a centimetre in length. Now, to put that in perspective, that is a millionth of a billionth of a billionth of a billionth of a centimetre. This size is referred to as Planck Length, the scale at which classical ideas about gravity and space-time cease to be valid and quantum effects dominate. It's the smallest possible measurement of length with any meaning and is about 10 to the minus 22 times smaller than a proton. Planck time is the time it takes a photon travelling at the speed of light to cross a distance equal to Planck length, and it's the smallest measurement of time that has any meaning and is about 10 to the minus 43 seconds. It's also the exact time it took for the universe to come into existence. Now, according to loop quantum gravity, space-time is made up of a matrix of these tiny loops, a bit like bubbles of soap, interestingly reflecting the cosmic web honeycomb-like structure of the universe on the grandest scales. But what it also means is that the very basic structure of the universe works on volume rather than specific particles of matter or force. It's an alternative theory, and one which has gained lots of popularity.